Okay, notes 120, we are on page number 6. What this is showing, please pause this, who's ever operated, pause it so you can copy down these words. Go. Okay, this shows cave formation, also called cavern formation. Usually how this works is if the bedrock is limestone and the water being slightly acidic, rainwater slightly acidic, if it goes to the ground it gets more acidic, acid will react with the calcite or even dolomite, but calcite mainly in the limestone, and it will dissolve some of it away. So what you see here is steps 1, steps 2, steps 3, and this could be usually in the range of thousands of years of this happening, thousands of years. So water gets in the cracks, dissolves some of it here, jump ahead another 1,000 years, there's more dissolved, and then jump ahead here. Now all of this area has been dissolved, and you have an open space underground. We'll call it a cave, we'll call that a cavern. Mildly acidic rainwater slowly dissolves limestone bedrocks. If you've ever been to a cave, how caverns, for instance, that's how this formed. I think I have some pictures here. Here we go. This is Carlsbad Caverns in New Mexico, and then this was all rock here. It's all been dissolved, washed away with in the groundwater, and then this is basically all formed, also different calcite formations. As the water dripped down, it forms these. These are called stalactites. Stalactites and stalagmites from the bottom here. How they form is like, here's some more Carlsbad Caverns. Very cool looking, very cool. This is in New Mexico. And what you have here is, this is a close-up. Basically, the water has dissolved some of the calcite in the rock, and then you have the water hanging off here, just a drop. A little bit will evaporate. The water becomes saturated with the dissolved mineral, which is calcite, and then it will precipitate out, become solid, like we saw the rock salt video in my kitchen, and add onto there, and then the water will drip off, and do the same thing on the floor. And that's just a little bit, probably a microscopic amount each time, but thousands of years, that will grow and get longer and longer and bigger. Okay, so that's cave formation. This is not really that. What I'm showing here is just this is out west, I'm not sure, with Utah maybe, and you see the flat layers of sedimentary rocks. What are they called? Beds or strata. And you really can see they've been uplifted and flat. You can see this one here, and it really juts out. And what that's showing is that this is more resistant to weathering. This has been weathered less, and this stuff has been weathered more. It's based on the type of rock that it is. Maybe it's the mineral composition, or maybe this is an igneous lava flow. But when it juts out like this, that means that it's more resistant. So now we get into the difference in how resistant to weathering different rock layers, rock types are, and what that may lead to. So, here's another picture here. Off in the distance, you can see these cliffs, and so you have more resistant here, and it makes sort of that cliff less resistant between, and it's been broken up into pieces more like soil and sort of pieces of pebbles and stuff like that there. You really can see it here. What I'm getting to is this. Please copy this down. Okay, pause it if you need to. What this is a picture of Niagara Falls, some of it here. This part's kind of blocked out. It shows a diagram here. When you have a waterfall, what needs to happen for a waterfall to be there is the top layer needs to be more resistant to weathering. So whether slower or less than the layers below it. That has to happen for there to be a waterfall. If that's not the case, they're all equally resistant, or they're more resistant down here, you don't get a waterfall. And so Niagara Falls are due to differential weathering. They weather at different rates based on type of rock, type of cement, something such as that. So, some sweet Niagara Falls pictures. Look at that one. That's a really cool panoramic. This is the Horseshoe Falls here. This is called the American Falls here. A very cool picture. Hopefully it comes through in the video. Good. What else we got? More Niagara Falls pictures. I like showing these are people here, and you really get a sense of the water rushing off. And you can see the rock layer right here. This upper rock layer is more resistant than the ones below, and that's why Niagara Falls is there. That's a blank slide. Okay, watch this. This is a pretty sweet animation that I did of how waterfalls form. Check it out. Okay, let's say this is our rock layers. This is a hill. We have different sedimentary beds. We're going to call this one green, purple, red. And then we're going to have let's say there is water flowing over. So now you have a stream flowing over, and the rocks rolling around in the stream and hitting the bottom is going to slowly wear this away. All the rock, sand, pebbles is going to chip away at this rock here. Give this some time, many years, hundreds, thousands of years. What's going to happen is all this gets eroded back. What I didn't tell you before is that these don't weather at the same rates. This green layer is more resistant than these layers here. As you can tell from here to here, not a lot of green has been weathered, but this really has been. It gets carried downstream. So now we're here. Okay, let's jump ahead another 500 years, 1,000 years, something like that. Long chunk of time. This, more resistant, this has been weathered more. Now you have the water really going off. It's faster. Any rocks here are hitting here much harder, able to weather it more. And what you have is this, and then it moves back, and a lot of the rocks bouncing back will do this. And then this, more resistant, will be hanging over. It can't hang over in, a very large amount because it won't be able to support it. So what's going to happen is that. So then that chunk broke off. Now that chunk is here. Now water still keeps falling off. Watch this, and this is going to happen. Okay? And that's going to happen, and then that's going to happen. And that's going to happen, and that's going to happen. Okay? And one thing you can notice is you still have a waterfall. The whole waterfall has moved back quite a bit. Large boulders down here, and you usually see that at most waterfalls, to have a lot of boulders down here, and this is what's happening. This takes thousands of years in this case. Okay, let's just go back. It is nice to speed this up, so I'm going to go a little quicker. In class, I usually speed it up. So, what we have here is, we have that. Stream flows over it. Weathering, this. Ta-da! That's pretty good. Homemade animation of the waterfall. I'm going to stop this episode right now.